Hey, fourth grade. So last week we were learning about multiplication and we're going to continue learning about multiplication today. So I just want to quickly remind you, multiplication is repeated addition. Let me show you an example or a few examples. Okay, so here I have 3 different examples. We have we have 5 classrooms with 20 students in each. If I want to know the total amount of students in all these classrooms, I could just do 20 plus 20 plus 20 plus 20 plus 20. Multiplication says, let's do that at a quicker rate. Instead of adding 25 times, we're just going to say, what is 5 times 20? What is 25 times? And that would be 100 students. Same thing here. We have 4 boxes and we have 3 oranges in each. So I could do 3 plus 3 plus 3 plus 3, or I know that 4 times 3 is 12. This last one looks a little bit different. In this one, we have rows and columns. I want to teach you something about multiplication. Typically in multiplication, you see things like this. You see a certain amount of groups. You see things in each of those groups. And then that equals a total number of those things. Just like we saw here. We have our groups are classrooms. We have students in each classroom. So groups times things in each tells us the total number. Same thing here as well. We have boxes. We have 4 boxes. We have things in each of those boxes. So we multiply, tells us the total number of those things that we have. This looks a little bit different, but maybe you're familiar with this. This is actually called an array. Have you ever heard this word? An array. So an array says that we can have rows and columns, and I can figure out how many total there are by multiplying. So pretend these are seats in a theater. And it looks like we have 1, 2, 3, 4, 5 columns. And in each column, we have a certain number of seats, right? Looks like we have 1, 2, 3, 4, 5, 6, 7 seats in each column. So 7 times 5 would be 35. That was just a quick reminder. Another quick reminder I want to show you is what we know so far. So far, we know how to multiply single-digit numbers. These are our basic facts, right? So we just multiply one digit by another digit. And I know you guys have been practicing these and you're getting really good at having them memorized and you can spout them out at the top of your head. Last week, we learned another way to multiply. We learned multiplication when we were using things like times 10 and times 100. We know because we understand place value and how those patterns work, that when we multiply a number by 10, it just moves over to the next place. So we were able to look at that pattern a lot last week. Just a brief reminder, multiplying with things like tens. Last week we were taking numbers like 20 and we were rewriting them. 20 is the same thing as 2 times 10. So we can write a new equation and we can replace 20 with this. And we can do 2 times 10 times 4. And we're going to get the same thing multiplying these as if we multiply this. Now what I didn't teach you last week is there's actually a really fancy word for this. Remember I told you can multiply in any order? So I can multiply straight across this way, or I can rewrite and do like 10 times 2 times 4, or 4 times 2 times 10. And no matter which order I multiply it, I'm going to get the same answer. That fancy word is called the commutative property. And I really hope I'm spelling it right. This property tells us I can multiply in any order and I'll get the same thing. 4 times 2 is 8, times 10 equals 80. 10 times 2 is 20. Times 4, 20, 40, 60, 80. That's the commutative property. But what happens when we can't find those tens? And what if we get something that looks like this? 13 times 6. Well, I can't break 13 apart to do something times 10. We know that 13 isn't a multiple of 10. We have 10, 20, 30. We can keep going on and on and on, but nothing will ever equal 13. So this won't really work. if you know anything about the number 13, it's actually, and here's another big fancy math vocabulary word for you, it's a prime number, which means it can't be divided evenly or into any set of groups, which means we have no basic facts that can multiply to get us to 13. So if I can't get any basic fact that gets me to 13, what is another way I can break down 13? Well, if I can't break 13 down by multiplication, maybe I could break it down with addition. I know that 12 plus 1 equals 13. I know that 5 plus 8 equals 13. I know 10 plus 3 equals 13. And you know what? I see a 10 and I love multiplying with 10, so I'm going to choose this right here. So right here I have 13 times 6, and I kind of wrote it out kind of similar to an array, except I made one box equal 1. So this line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And over here I have 1, 2, 3, 4, 5, 6. So if I have 6 rows and I have 13 squares in each, I want to figure out the total amount of squares in this picture. So what I could do is I could count out each square to get my total. We know that's not as efficient as multiplying. So I'm thinking about how I previously just broke up the number 13. I said 13 was the same as 10 plus 3. So what if I find 10 squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what if I cut this picture right here? So over here, this is 10, and this over here is 3 left over. Okay, well now I know in this little area right here, 6 times 10, how many squares are in this area? That's right, 60. So this is 60 squares. How many squares are in this little area? Well, there's 6 rows and there's 3 in each. So 6 times 3 is 18. So how do I get my answer from here? I know that I have this many squares over here and this many squares over here. So how many squares do I have total? Well, simple. All I need to do is add 60 plus 18, and that would be 8, 7. So 13 times 6 is equal to 78. Now this is a little bit different than what we've been doing earlier last week. So let's break this problem down a little bit. We had the problem 13 times 6. We took this 13 and we rewrote it. 13 is the same thing as 10 plus 3. So we knew that we needed to multiply 6 by both of those pieces. So we needed to multiply 6 times this 10 to see how many were in this box, and the 6 times the 3 to see how many were in this box. So we did 6 times 10 equals 60, and then we did 6 times 3 equals 18. Because we broke this number down into an addition equation, we had to multiply each piece of it by this 6. So we did 6 10 times, and then we did 6 3 more times to get our total number of 78. Now, you're just getting all the math vocab today. This is called the distributive property. I'm going to spell this wrong. Distributive property. And if you're using your good reading skills, you might notice the word distribute and distributive. Distribute means to give out or to pass out. So we had to distribute this 6 to the 10 and the 3 because we know both of these make up that 13. Now what I want you to do now is think, How could we have broken up the 13 a different way? Let's say I wanted to break the 13 up. I know 13 is the same thing as, how about 6 plus 7? 13 is the same thing as 6 plus 7. So if I go over 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So this is 6 and this is 7. What's 6 times 6? You got it, 36. So there are 36 squares inside of this big square. Now over here, what is 6 times 7? 6 times 7 is 42. So now if I add all the squares over here with all the squares over here, I would get, again, the same answer, 78. Can you try to break up 13 a different way? We already did 10 plus 3, and we did 6 plus 7. I want you to pause this video and go ahead and break up 13 in a different way. Then draw a model just like mine and see if you come up with the same answer. Okay, hopefully you got 78. Now, this is just one strategy you can use to multiply numbers when you can't find the tens or they're not basic single digit facts. So hopefully this was a little bit of a good start for you. And we're going to come back tomorrow and we're going to look at something very similar to this, but we're going to take it up a notch. I hope you're ready.